Everyone, welcome back to our AI engineering crash course. In this video, we'll talk about LLM frameworks. Just as a recap, we talk about AI engineering in the first module, we talk about prompt in the second module, and this is the third module where we talk about APIs in general. We went through the OpenAI API, the Anthropic API, Google, Rock, XAI, DeepSeek, and some hosting providers like Together, OpenRouter, and Replicate. In this video, we'll talk about frameworks like LangChain, Haystack, and LLamaIndex. So I will be giving you an overview of these frameworks with some small sample code so you see how you work with them. But most of these frameworks are made for retrieval augmented generation, which is our next module. So what will happen is that I will be giving you a real project using one or two of these frameworks in this section or in this module, where I will first explain some high-level concept to you before going through a real project. Otherwise, if you do it here, you will have a lot of knowledge that you will not, there's a lot of concept that you will not grab directly that we will first need to explain here before we start working with retrieval augmented generation. So let's get started. As you see here, we have a simple static row with each of these provider, each of this framework. So we can go through everything they're offering and how you can take advantage of this framework. So let's first start by LangChain. LangChain is actually an ecosystem of tools that you can merge together to create an application. It's one of the first LLM framework, and it was built to abstract the LLM logic from the application, so you can easily switch between providers, easily adapt to many different APIs without having to rely on each API specification. Today, a lot of these API providers actually support OpenAI. It wasn't the case before. But even with that, as you saw it last time, function calling can be different from provider to providers. Same for how you actually do some few things. And if you really want to support all of these providers and be flexible enough in your code, LangChain, Haystack, and LlamaIndex can be really helpful. Same for having an ecosystem of complete tools, so you don't have to code everything from scratch. For example, PDF loaders, vector store connectors, and many other things that we'll see in the next part of this video. So let's first start by giving you some overview of all of the LangChain ecosystem. The first thing is prompts. LangChain gives you an easy way to work with prompts. It can be with templates, templating engine for your prompt, so you can directly write a prompt with some variables that you can use later. And it also offers you a prompt hub, so you can pull prompts from people from the community. If you don't know how to write good prompt, you can actually just search there. If you find a good prompt matching your use case, you can directly use it. So let me just give you LangChain hub. If you go in LangChain hub here, you will see that you have a lot of prompts. So maybe you can just pick one. Rack prompt, super agent, React. I think we talk about React in the prompting part. Yes, so you can just choose here from the hub the prompt that suits your case, and directly integrate it into your code. Otherwise, we have the vector store. That is a concept that we'll talk about in the Rack module. So subscribe to see that video coming next time. You have the document loader, the text splitter, also concept that we'll be explaining in the Rack module, but in general, they actually use to work with documents and to be able to feed a context to your model that's actually based on some document or some web page or some other tools. The output parser, we have the models as well. The models is quite interesting because LangChain actually abstract the model logic from the implementation, as I mentioned before. As you can see here, we have different models, right? So you'll see that only the model name, the provider, and maybe some API keys will change when we'll switch models. So if we switch to OpenAI, if we switch to Anthropic, we switch to Together, you'll see that you can easily change your application logic without having to completely change everything. You can easily change your API provider without having to change your complete application logic, which is pretty interesting. So let's say you're working with OpenAI and suddenly DeepSeek cut costs by 10% or 50%. You want to switch there. Instead of re-implementing everything you did in your code with maybe the new DeepSeek API, the good thing or the best thing now would be to just change. If you used LangChain before, would be to just change the provider, the model, and the API keys, and you're good to go. So in the last video, I showed you many providers, and most of these providers are actually supporting OpenAI API. It wasn't the case before. And even with that, you will see that just a fraction of what this model can do is actually supported with the OpenAI API base URL trick. So you still need to have an abstraction to be able to work with different models easily. And you can see down there that and LangChain support a lot of models. So you can choose the one that suits you, local LLM, it's different providers from different, you can choose and integrate it into your app. And as I mentioned before, it will actually be the same thing. So I think Korea is one of the providers that we didn't talk about in this video. And you will see that the module that you're using, these human messages, this chat and everything in abstraction will actually be purely abstracted from the library itself. I think AI21 Lab is one of the providers as well. We have a video about Korea, AI21 Lab, and OpenAI when they were the three provider on the market. It's on the channel. You can check it out. Yeah, and as you can see, you will see that you have this implementation here, and you can have nearly the same logic with the chat prompting with the chain, where you put the LLM here and you can change the LLM to any other provider. The same logic and the same code will work. So that's one of the powerful features of LangChain. And now the tool ecosystem. This is one of the most important thing working with LangChain. It is the tool ecosystem. So if you type LangChain tools, you will see that I think it's this one. No, not this one. This one. Okay, you'll see that you have a panoply of tools here. Okay, if you want to code this yourself, you will pass a lot of time coding a Bing integration, Brave integration, Google integration, and GitLab integration, GitHub integration. So you will see on this page that you have so many integrations that it makes it Google integration, Google Drive, that it makes it extremely easy for you to work with all of these tools. So if you're building an app that's supposed to connect to one of these providers, LangChain is the right framework. Same for other providers that we'll be talking about here. So using a framework instead of building everything from scratch, using maybe OpenAI API will be better. So you don't have to recreate the where. You can just use the modules, give the folder maybe, and load everything from Google Drive. Building this is quite complex if you want to do it yourself. So using a framework is the right way here. Okay, so with that said, I can show you some sample code. We'll just build a sample LangChain application later, but let's just go through the overview of all of this framework, and then we'll go through the code later. Here we'll see Haystack. Haystack is actually framework from DeepSeek, not DeepSeek, but DeepSeek. So let me show you how it's written. DeepSeek like this, not DeepSeek. Okay, DeepSeek like this. Okay. Yes. So they created it around the same time as LangChain, and the specificity or the speciality of this framework is that everything is built as a pipeline. It makes it pretty easy for you to chain multiple process that look like a pipeline that will fit into a pipeline. Especially document processing or document integration with tools and things like that. So you can see, for example, here in this image that you have generators, which are actually, just LLM providers, embedders to actually, I think we'll talk about it later, to compute embedding and save it. Retrievers to retrieve, these are vector stores, document, and then ranker, router, preprocessor, and a lot of these things that you can just compose and create a pipeline out of it. And the pipeline will be something like this. You get a query, you embed the query, talk about it later again. You will create the query later on. You create your prompt, and you generate a response using one of these tools. So Haystack is actually quite interesting when you want to do retrieval augmented generation as well. But it's not limited to that. You can actually build AI agents with it, and many other things. Now, LLamaIndex. LLamaIndex was first called GPT Index, and it was a module built on top of LangChain to specially work with documents. I think they extended it, they changed some modules. Now they are being a bit more independent from LangChain, but at the core of it, it was mainly built to work with documents. And that's the reason why I mentioned we cannot really use these frameworks without talking about augmented generation. But in general, it's kind of the same thing. If you go to Llama Hub, you will see that. Let me go to LLamaIndex Hub. You'll see that we have kind of the same thing, right? We have kind of the same tool that you have with LangChain. So if you search for data loaders, you'll see that you have here web page loader, Reddit reader. I don't know if you have Drive here. Google Drive reader, Google Calendar reader. So we nearly have the same loaders. It's actually the same ecosystem as LangChain, nearly the same, just that it's purely built for data. So it's mainly interesting to work with LlamaIndex when you want to work on top of data. Yes, so that's the reason why you can see here that you have this vector database, vector database, and integration with tools. And LlamaIndex actually orchestrating working with all of these tools, the database, and the providers as well. Basically, all of these tools actually help you build AI application easily. LangChain is helping you with the ecosystem and compose them to build complex applications. It can be AI agents. LangChain actually have an AI agent framework. We'll see that in the upcoming modules of this video called LangGraph. Haystack is actually interesting as well to build application using the pipeline architecture. And then LlamaIndex is quite interesting when you want to work on top of data or documents. Okay, so let's go through some sample code. I will just show you some sample code of LangChain, Haystack, and LlamaIndex, and we'll go through it together. Okay, so here we have our framework folder. Okay, it's empty for the moment. So let's create a new terminal. Okay, it's already there. Let me go to the framework. First thing first, we create a virtual env. Then resource vm /bin /activate. So that's done. Now we need to come here and create a .env. So that's the first thing. Why? Because we'll be working with providers, and the best way to keep our API keys secure is to create a .env. So let's do .env here. I'll be pasting some keys here. I'll actually show how to do this in last tutorial, so you can watch it again if you want to see how to create an API key and other. So what we'll be doing here is that we'll be giving the document loading functionality to OpenAI. If you see it from the Gemini point of view here, we did document loading, PDF loading. For Anthropic, same. We were able to load PDFs directly, but unfortunately, we don't have the same functionality. We don't have it here anymore. But unfortunately, we don't have the same functionality with OpenAI. So we'll try to give that functionality to our OpenAI API today. So let's create a file. The first example will be with LangChain. LangChain test. And don't name your file LangChain, otherwise we'll have a problem with importing your modules. Okay. With this, what we need to do is first install all the required modules to work with LangChain, right? And these required modules are quite simple. Let me just put a requirement.txt here, requirements.txt. In this requirements file, we'll put LangChain community, LangChain core, LangChain OpenAI, basically LangChain modules. And we can actually install that just by keep installing LangChain and all the providers that are related to LangChain. But I think we have it here first. Okay, here, put it here. We also need the dot here dot env. Okay. Okay, so now we can install these modules and start using it. So here, pip install. Yeah, we need some PDF processing part as well. So let's put this here for reading our PDF and transforming it into documents. Install requirements. Okay, installing everything. And then what we need to do is to import first all the modules that we'll need. And for that, we need to import the OpenAI chat. Let me see here. First, install OpenAI, import it. We need a prompt template. I think we talk about prompting and the prompt template that LangChain comes with it. You will see how to use it here. And then we need to install the PDF loader here. And as usual, we need to load our .env, our environments, to load the OpenAI key into our environment. What LangChain is doing actually is that it's getting the key directly from the environment, so you don't have to pass it directly. But if you can actually pass it if you want to, but it will read a variable called OpenAI API, OpenAI API key, the way we have it in our .env already, so it's fine. So with that, what we need is to create a PDF here, and this PDF will be what we will be working with. Okay, so let's paste the PDF here. Okay, this PDF is actually just some it's how's it called, RFS from request for startup from YC, and we'll be just building something that will read through it and just summarize it quickly. And you can build some things to suggest startup ideas directly based on this RFS as well. You are free to exploit it as you want. In this video, we'll just be summarizing the content. Okay, so with that document, what we need is to load the content. And to load the content, we use this by PDF loader. It's pretty simple. You will see that we have here by PDF loader, we pass the name of the file, and we load the file. This PDF will be loaded into different documents. So if we print this, print documents, okay, and we go in our, let's clear this, and we do pip of Python LangChain test. Taking some time, and you will see that we have many documents here, okay, with the metadata like total pages, the actual page, the page label. So maybe if you extract something from a specific page, this is actually made for RAG, and we'll talk about it later again. But if you extract something from a specific page, you can actually highlight it and give it as a source. But here you will see that it read the PDF and cut it into chunks, or into documents, not chunk, into documents. And you will see the page actually request for startup. At YC, we often discuss ideas that we'd like to see more people working on. So with that said, we can delete this. And our next thing will be to merge all of this document. For the moment, we do not do vector storing, semantic search, and things related to RAG. I will just be feeding the whole document to the AI. In the RAG part, we'll be optimizing this to make sure that we only feed the part that we need to the AI. But okay, for the moment, we'll just go through the documents and merge them. Okay, we're going to the next line after each document. And then with that, we need a prompt template. This prompt template is actually a custom prompt template where we have two input variables. We have here the PDF content and the query. Okay, so you can create a prompt template like this and use it in multiple apps if you want to. You just have to pass these two variables, the prompts, the PDF content and the query every time you call the prompt template. And then we create our LLM instance. Okay, so here we pass the model name. It can be GPT-4o as well. I'm just trying to be cheap. We pass the temperature, and then we have our chain. So what we do here is that we compile our prompt like this, we passed a query variable and a PDF content. So the query variable, we need to create it. It will be this one, saying summarize the key insight from this report. It will just go through the PDF that we loaded here. That will be passing with this variable down here, and send it to the LLM to summarize. So how do we do to send it to the LLM? We do LLM.invoke and we pass the prompt, which will have this variable replaced already and this variable replaced as well. So, okay. And after, we just print the response. So if I clear this and I run it again, taking some time, and you will see the response from the AI here. The report outlined a list of startups in the AI and software engineering space, including Secure AI App Store, data center, compliance, and audit. So this is a good summary of the document, but this is quite bad in terms of implementation. Why? Because you are feeding a 5-page document to the AI, which is pretty expensive. In the RAG part, I will show you how to cut this document and just feed the specific part that the AI needs to know to answer the question. Okay, so LangChain test is done. Let's do the same with Haystack. Haystack test. Goodbye. Okay, but to work with Haystack, we need to install Haystack modules and modules from Pi. And for that, we need Haystack AI. So let's add it to our requirement and install again. You will install the missing modules. Let's just install everything with LLamaIndex and everything, so we don't have to do it every single time. Okay. Okay, I think everything is installed. So with Haystack, we have kind of the same process. Okay. We first, of course, import the modules. Let's just import everything directly here. This will help to read the file. This is actually an internal package, an internal object of Haystack to actually help you build pipelines. And these pipelines are based of components, and these components will just be what you will be putting into your pipeline. It can be retrieval, it can be a tool, it can be a provider, but in general, you need this component into your pipeline. Okay, so now that we have this, as usual, we need to load our env variable to be able to use it later. Okay, great. So now, same, we need a prompt template, but this prompt template will just be simply a template like this. And for a Haystack compared to LangChain here you have one single bracket. Here you need double bracket. And what's interesting here is that it works like a template engine, which means you can do for loops in there if you have an array, for example. Okay, so with that said, let's create our pipeline. We have this. Okay, and then we add some components to our pipeline. So we first add the prompt. So our pipeline starts with the prompt. I think we need to do this. Then we have the AI that will get the result from the prompt. The complete prompt will get the AI, will be fed to the AI, and the AI will generate something that the answer builder will take. You just added component here. Now you need to create the logic, and the logic will be connections, which we'll do here. And then we connect this like this. Yeah. So it's just saying that our prompt builder here is connected to LLM, and our LLM replies will be fed to the answer builder replies. So this will look like a pipeline. You can actually grow it like this to see how it looks like. So let's do that, and we need to just Python Haystack. It will, if everything's right, it will create a file here, and this file will be this. Okay, so I'm just zoom through it. You see that we have the prompt builder that takes PDF content, question, and some other variables. This prompt is a string at the end that's passed to the LLM here. And this LLM get the system prompt, streaming, callback, and other, and send replies to the reply builder, and the reply builder will just generate the result with it. And the metadata if needed, the meta as well. So, yeah, so we get it here. So what we need now, we have our pipeline already built and visualized here. We just need to call it, okay? And to call our pipeline, we need to feed the information that we have, which is actually the PDF. And to do that, you need to call the PDF module and convert it into documents, okay? We read it and we convert it into documents, and we do the same that we did with LangChain. We transform that and save it into a single variable. Normally, this document, you save it in the vector store, but in our case, we're merging them and putting it into a document. Now, we have the query, which is our question here, same as LangChain. And then we just run our pipeline, okay? Running the pipeline is as simple as doing this. From builder, question, you pass a question, PDF content, you pass a PDF question. These are actually what you get here. This and this is actually the parameter of your prompt builder, right? That's the reason why you're passing it here. And each of the pipeline component, if it needs a specific input, you need to pass it as a parameter here. Okay. So great. Now we can print the result. Like this. Let me just okay, and run it again. Taking some time. So in the meantime, I can create directly LLamaIndex. Index. You can see that it worked properly, right? We have the report here. We built our pipeline and we we run it here, okay? And it's working properly. So now for LLamaIndex, it's nearly the same process, okay? First, we import the modules, okay? Same. We have this. This is quite specific. That's the reason why we have this PyMu PDF here. We install this. We use OpenAI path, as I mentioned, to read the file on the system. Chat message load.env to load the environment variables. So we load them here. Okay. Now we need to read the PDF, and same. You will see that they actually have the same high-level logic most of the time, but the architecture is quite different. So here we merge them. I actually explained that already. We create a prompt, same, but this prompt is actually just a normal Python template. And then here we create our LLM with the model and temperature. And as usual, the API key will be directly extracted from the environment variables, okay? And then here we create a message. This is actually quite close to OpenAI. So we imported the message module, the chat message module here, and we create the system and the user message here. And then all we need is just to run this by doing this and then printing the response, okay? And then let's run this Python LLamaIndex test. Taking some time. Okay, great. So we get the document outline, very startup AI and technology. You'll see that LLamaIndex is quite fast. It is purely optimized to work with documents. This is a really simple use case, but you can do complex things on top of document with LLamaIndex. Yeah. So I think that's it for this video and for this module. In the next part, we'll talk about retrieval augmented generation, where you will understand in depth how to work with documents and how to work with tools, and also how to use these frameworks to make this whole process pretty easy. So thank you for watching and see you in the next video.